Hello my dear students. So let us continue our discussion on the structure of atom. Okay, in the last class we have discussed the basic terminology we will use in the chapter and also related to chemistry, and the next thing we discussed about photoelectric effect, and the next Planck's quantum theory we discussed. Right now wave nature, I mean what are the characteristics of waves we discussed. Okay, and also I have shown you few questions now. So today I am going to show you how can we solve this kind of questions based on Bohr model. So our class is based on what today? Our topic is Bohr's model. Okay, we'll discuss about this and we'll solve these questions after the discussion. Okay, now again we need to also study about this de Broglie wave equation and all. I will tell you all these things now. Yeah, just give me a quick recap of last class. What is the equation we got in photoelectric effect? Energy supplied equals to work function plus kinetic energy you have written. Okay, so based on that I have given these questions as a work. Have you tried this? Tried this. So what is the answer you got for the first question? Option 1. Is it? So how can you do this? Tell me. See, calculate the frequency wavelength of photon with energy this much. So you have like calculate frequency wavelength of photon with energy they have given. Energy is given now. So E is equals to h nu you can use. Okay, given it as 3.98 into 10 power minus 15 joules. Okay, h 6.6 into 10 power minus 34 joules seconds you can take. Okay, multiplied with frequency. So frequency you need to find now. So just these are the things. See, joules we got removed. So we can get our answer in terms of second inverse now. So nu will be 3.98 I have. So I am taking it as 4. Okay, into 10 power minus 15 by 6.6 into 10 power minus 34. So this will be around how many times? See, if it is 35, remove 25 from that. So we will be getting 20. So it will be 19 now. Right now? 19. And the next what we have 4 means this is 2, 3.3. Okay, if you put 0, so it will be around how many times? 6 times. Okay, so it will be like this. So 6 into 10 power 18, can I write? Just out of this 19, can I write it as 10 power 18 into 10 power 1? Can we do like this? So multiply 10 here, we will get this answer. So we have first option as like that. Okay, you can also verify now its wavelength. What is the wavelength formula? Frequency equals to C by lambda you have now. So we got frequency, you know C value, find the lambda value out of it. Clear now? Very basic. Again threshold frequency nu naught is given. Okay, now what they are asking, what is the work function they are asking. This is also finding energy only. See, I have given energy supplied equals to work function plus kinetic energy. They are not asking about energy supplied, they are not asking about kinetic energy, they are asking about this work function. So work function is nothing but, that is also energy only. So work function is nothing but energy only, but that is the energy required to eject the electron. Okay, so this is also equals to h nu, but here I am saying nu naught. That is the minimum frequency required, threshold frequency. Given threshold frequency is this much, so substitute over here, multiply with Planck's constant, you will get work function. Hope it is clear. Let's move forward with our Bohr's model. Okay, so what do we have here? Tell me. Yeah, see, in this Bohr's model, let me take all these postulates. Okay, see, so what are the postulates we have? See, atom consists of a small heavy positively charged nucleus in the center. Okay, if this is a center part where we have positively charged is concentrated. Okay, in which around the electrons revolve. Okay, so around this we have circular paths in which electrons revolve, right now. Next, electron revolve only on. Now, these circular paths are called orbits. What is that? Orbits. Only those circular paths allowed in which their angular momentum is quantized. What is that? I will tell you. Okay. So now these circular paths, see, they will be having fixed radius. See, I am taking here, this is the nucleus, okay, around which we have circular paths. In this, electrons are revolving, I am saying. Okay. See, now the distance from the center of this nucleus to this circular path is fixed now. Okay. And also, see, here also it is fixed now. So for circular paths, it is having fixed radius and fixed energies also. Okay. If electron present in this orbital, this orbit, it will be having different energy, and if it is present here, having different energies. Okay. So now the orbitals of the orbits have fixed energy, so we can also call them as stationary states. Okay. So only those orbits are allowed whose angular momentum is quantized. So angular momentum means what? See, let us say I have an electron present in this orbit. Okay. So this is at a distance r from the nucleus. Can I say like that? Yeah. So moving with some velocity v. Okay. And see, electron has some mass also now. So I am representing it as me, mass of electron, and see, it is making some theta angle with this direction. See here, when it is moving like this, we have a theta here. So sin 90, I can say theta 90 degrees. Okay. So now angular momentum L is equals to, we have mass, velocity, radius, mvr with some theta. So I am taking here sin theta. Okay. So what is our sin theta? How much? Sin 90 here. So sin 90 is 1. Sin 90 value is 1. So you don't need to remind or remember all these things. Just final conclusions are required. Just I am giving this as a basic understanding purpose. So we got mvr, angular momentum equals to mvr. So this should be equals to an integral multiple of h by 2 pi. So it can be n times. nh by 2 pi. So based on this is the first equation. So now using this equation, we have the other equations derived. Okay. So we can able to find its radius. See here, what are the things we have? Radius, and we have velocity. These things we are going to find. Already mass of electron is fixed. How much it is? Last class we discussed 9.1 into minus 31 kg. Okay. Yes. Yeah. So now other postulates are also there here. So this is just for your information purpose only. Just read this. Okay. So now, so here I have written, what I have written, mvr equals to nh by 2 pi. So what is our n there? So these are like 1, 2, 3 numbers. So which are also called as shell numbers. Like this I am writing now. So this is n equals to 1, n equals to 2. As we go away, 3, 4, 5, 6 like that we will get. Or you can also represent them as like k, l, m, n shells. Okay, these are called as shell numbers. Okay, later we are calling them as principal quantum numbers. What is that? Principal quantum numbers. Okay, now here we got this one. Okay, so now what he told is, during the revolution of this electron around the nucleus, it will not emit the energy or it will not absorb the energy. He told like this. If in case, if it emits the energy, what I am saying, if in case, first of all it won't emit, he told, then later he said, if in case if emits the energy, see, electron is emitting the energy. Now what happens? The energy of electron decreases. It means it will be going to the lower energy state. It means here is the electron emitting some energy. So now that electron falls into the next lower energy or corresponding to the lower energy based on the amount of energy it is released. Okay, and if in case it absorbs the energy, now what happens? Electron will excites to the higher energy level, next higher energy level corresponding to that absorbed energy. Is that clear? Now this statement or this postulate gives us the explanation for spectrum. It means Rutherford unable to explain what? Atomic spectrum right now, but he is able to explain this based on this emission and absorption of energies. Okay, we can get absorption spectra and emission spectra from this statement. Okay, and then next, See, I am not going to give you the derivation and all. Okay, see how this derivation, like finding this radius and all we got here, is by using a simple equation, that is, see, there is a failure of Rutherford. What is that failure? See here, Rutherford just told that we have a positive charge at the center, electrons revolve around it. But he is not explained how this electron is not falling into the nucleus, because we know if opposite charges are kept together, what happens, that that electron will come and falls into this nucleus, yes or no, because oppositely charged. So by revolving around it, it will loses its energy, and following the spiral path once comes and falls into this nucleus, and atom should get destroyed. This is the main drawback of Rutherford's explanation. Right now, for this, what Bohr told is, he given the explanation like this. If this is the nucleus, here electron is present. Okay, now between this nucleus and electron there is force of attraction like this. Okay, I am saying it as F1, force of attraction. Okay, now you take one thread and a stone, tie that thread to that stone, just rotate it like this, and if we leave it, what happens? Will it come towards you, or it will go away from you? It will go away from us now. So it means there are two types of forces for this electron. One is inward force with respect to this oppositely charged species. Now there is, since it is rotating in this orbit, so it also have some outward force. Let us say that outward force as F2. So what he told is, so when this F1 and F2 are equal, then electron will not fall into the nucleus, it will stays here only. Right now it will not get destroyed now. Okay, so based on this approach, he given that the calculations for radius and the next energy, velocity, all these things. Okay, so now I am not explaining all those things because it is, you may feel it is too much heavy. So I am directly giving the formula, based on that we will do the questions. Okay, so what he found, the radius of an nth orbit, electron in the nth orbit, is equals to 0.529 into n square by z angstrom units. So this is the formula you should remember. So what I am saying, radius of nth orbit of hydrogen like species is equals to 0.529 n square by z. So what is this n indicates? Shell number, I told now, shell number. Shell number. So what about this z? Atomic number. Okay, so write these things. So that is in terms of angstroms. Now here we have in terms of picometers. Okay, they may ask you in terms of picometers, nanometers, centimeters, meters, angstroms, anything you should be able to convert them. Okay, so now calculate, I am giving you one basic question here. Now calculate radius of, or radii of first Bohr orbit of hydrogen atom. Tell me, what is the first Bohr orbit of hydrogen atom radius? 0.5. So R1 of hydrogen I am asking. So what you will do? 0.529 into n square by z. What is our n value? First Bohr orbit. N value is 1. Z, atomic number of hydrogen, 1. Both are 1. So you will be getting 0.529 angstroms as your answer. Okay. Now in the exam, they will ask you a question like this. If radius of first Bohr orbit of hydrogen is A0, then radius of third Bohr orbit of helium ion is dash in terms of A0s. In terms of A0. This is the question Similar to this, there is a p by q. I will show you now. Okay, so tell me, what is the radius? 9 So how can I solve this? Radius of what I am asking? R3 of helium ion. Okay, now are you observing this thing? See, here I have taken hydrogen atom. In the second case I have taken helium ion, not atom. What makes the difference?
The charge. It loses the electron.
See, helium atom if I take, it has 2 electrons. Here I am taking helium ion. How many are there here? Only 1 electron. So it means you should get one clarity here. The Bohr atomic model is applicable only for single electronic species. It means the species contain only 1 electron. So give some example for single electronic species. Hydrogen atom, helium plus you should say, Li plus 2, then like this, Be plus 3, like this species only. Should not applicable for this helium atom or lithium atom. You should not applicable for should not apply this Bohr model to that. You will get the wrong answer. Okay, is that clear? So they will ask you 4 options. They will mention for which of the 4 options or which of the following will follow Bohr's atomic model or valid for Bohr atomic model. So you should identify that single electron species only. Okay, now that's why here it is mentioned helium plus. Tell me what is the answer? 0.529. So R3 of this helium plus is 0.529 n square by z I am taking. So this will be 0.529 into n square is how much? 9 by z 2. Okay, so we got 9 by 2. So what I am asking in terms of A naught, I don't want this answer, I want in terms of A naught. So A naught is the radius of first Bohr orbit of hydrogen. So first Bohr orbit of hydrogen is how much? Just now we did in the previous case, 0.529. So this value is considered as A naught, right now. So I can say this as A naught into 9 by 2. So your answer should be 9 by 2 A naught. Is that clear? Take one question as a homework, I mean just for practicing purpose. Take the radius of, write the question, the radius of second Bohr orbit of helium ion, helium positive charge, helium plus is x. Then the radius of lithium plus 2 ion is dash. Second orbit, here also second orbit, for both it is second orbit only. The radius of second Bohr orbit of helium ion is x. Then the radius of second Bohr orbit of lithium plus 2 ion is dash. In terms of x I want. Okay, so you can able to do this. Second orbit only, but atomic number is different here. Okay, that's it. Can you able to do this now? Yes. Let us move forward with few other things. Now, first thing is radius done. Next we can able to find velocity also. So what is the formula we got here? Velocity of electron in different orbits. Okay, so v of an nth orbit, n can be 1, 2, 3, 4 like that. Okay, is equals to 2.18 into 10 power 6 z by n meter per second. Okay, so Vn. Okay, so they will ask you few questions like this. Which are the following is are correct? Correct. You can have multiple selective type questions, na? MSQ type questions also there in exam. So like this. So V is proportional to Z, option A. Option B, V is proportional to N. Option C, R is directly proportional to Z. Option D, R directly proportional to N square. So tell me. V is proportional to Z, directly proportional, yes. So first option, any other? Rn is proportional to, that's what. See, very simple questions, not even minutes also passed, you have got confused from this. See what you have studied here, n square by z, Rn equals to n square by z, right now? So directly proportional to n square, inversely proportional to z. So be conscious when you are learning something new, okay? So here Rn is, I can say Rn is directly proportional to n square and inversely proportional to z, yes or no? So what are the options correct here? A and D, is that clear? Okay, if I add one more option, Rn is inversely proportional to Z, this is also correct. Clear now? Yeah. So have you written this formula? Yeah, write it fast. Next one is energy of an electron present in that nth orbit. First one is radius of an nth orbit, second one is velocity of electron revolving in nth orbit, third one is energy of an electron present in some nth orbit. Okay, so how can we give En, energy of electron in nth orbit, is equals to, there are different formulas here, the important one or more usually you will see is this one, minus 13.6, see here, minus 13.6 z square by n square electron volt per atom. Okay, but you need to write all these formulas. Okay, this joule per atom also useful sometime. Okay, we don't know in what terms they will ask you. Done? Write this first. Done? So write a question based on this. Here joule per atom, this is kilojoule per mole. These two are more important, you will be seeing more usually, but write all these three first. Okay, write a question based on this, we will solve. Question is energy of an electron revolving in second Bohr orbit of hydrogen atom. Energy of electron revolving in second Bohr orbit of hydrogen atom. Easy. What is the answer you got? En equals to minus 13 point, in terms of electron volts you can say. Answer in terms of electron volts. Okay, minus 13.6 hydrogen atom, so 1 here, 1 square, and n value, so you can take 4 here. Okay, electron volt per atom. Okay, so this will be 3s are 12, okay, 1.6, so 0.16 4 times. 3.4 electron volt per atom. Got it? Now for first Bohr orbit of hydrogen atom, how much? Minus 13.6. Second Bohr orbit? Minus 3.4 electron volt per atom. Like this, if you keep on solving for third, fourth, fifth like that, so you will get something like this. The values are something like this. So first one is how much you got? Minus 13.6 electron volt. Second, minus 3.4 electron volt. Third, minus 5.1 electron volt. Like this, if you keep on solving for infinite orbital, n equals to infinite I am saying. So En equals to minus 13.6 z square by n square. So n value is infinite here in this case. So something by infinite, 0. Okay, that's why the energy of infinite orbital will be 0. Is that clear? Now if you observe, so what is this negative energy, sir? See, energy is having some negative sign. It means if you have an electron independently existing, consider its energy is 0. Now compared to that independent existing electron, how much stable the electron when it present with some nucleus. For example, that electron is present in the hydrogen atom in the first shell. This is this much, like this energy is indicating now. So this is the lowest energy when we compare with the independent electron. See, lesser the energy, more is its stability you should consider. So minus 13.6 electron volt is the energy which is lowered when we compare with the independent electron. Like that you can understand from this. Okay. Now this will be the most stable state, ground state. Okay. As energy increases, stability decreases, you can understand like that. And one more thing, if you observe here, as n values increases, see, as n values increases, what happens to the energy? It is becoming towards positive value, like towards 0. See, more negative, it means lower energy. Therefore I can say as n value increases, energy increases. Is that clear? Next thing is, as n value increases, what you can make a statement now. As n value increases, see, as n values increases, energy increases, but energy gap between the shells decreases. See, first energy gap is 10.2 electron volt. Second energy gap is, it means energy gap what happening? You can make a statement as n values increases, as n value increases, energy also increases, but energy gap between shells decreases. Yes or no? Yeah. Let us move forward. So there are other two formulas, you just make a note of it, but they won't ask you, but just make note of it. So time period of revolution of electron in nth orbit, how much time it is taken for one revolution by an electron? So T equals to 1.5 into 10 power minus 16 n cube by z square. Okay, so what is the units for frequency you have studied? Units for frequency, hertz or second inverse also. Okay, so this is nothing but frequency, I can say 1 by t. Second inverse na time means here second it is second inverse or hertz. So frequency of revolution is nothing but 1 by t I can write. So this becomes reciprocal here. Reciprocal means the constant value becomes this much, 6.6 into 10 power 15, and this will become, see, z square in the denominator, it is numerator here, that's it, write it as it is. Okay, clear up to here? Yeah. Now you have seen this these energy levels, right? Okay, so now we need to understand spectrum, where we have some questions from this part also. So for hydrogen atom, I am taking the hydrogen atom spectrum lines, spectral lines. Okay, so now I have different energy levels, N1, N2, N3, N4, N5, something like this I have. Okay, let us say I have an electron present in this fifth energy state or fourth energy state. Let us say I have electron in this fourth energy state. Okay, so now when this electron falls into the ground state, in which spectral region we can get? Like that also they will ask the question, I will show you. So now how many possibilities are there to de-excite this electron or to come from the ground state? From fourth energy to first state, ground state. Ground means first, n value 1. First excited state means First excited I am saying. Ground state is n value 1. This is the ground state. First excited means n equals to 2. This is first ES you can write. Okay. So now here what I am saying, electron is present at 4th energy level. So let us make 4 lines. N equals to 4. N equals to 4. 3, 2, 1. Okay. Like this I am making. So now electron present in this level. Okay. So it can directly comes to the first, directly it can come. Yes or no? Yes or no? Or it can come from 3, then 2 and to 1. Or it can come to 3, 3 to directly 1 or 2. Is that clear? What I am saying? What are the possible lines they will ask? Number of possible spectral lines when an electron falling from nth level to ground state, or from nth level to first excited state, or from nth level to second excited state. Like these questions you can see in the exam. So now how many spectral lines possible here count? Is there any other possibility we have? No. 2 to 1 already written, no? See, 2 to 1 already there. Possibility I am asking. Okay, now count the number of possibilities. 1, 2, 3, 4, 5, 6. 6 possibilities are there. See, every time writing this many possibilities it is difficult. So you can use this formula directly. What is the formula? Number of spectral lines possible. For any possible thing you can use this formula. Number of spectral lines, possible spectral lines you can write. Possible spectral lines is equals to half into n2 minus n1 into n2 minus n1 plus 1. So this formula you just remember for all possibilities. Okay. So now just put this value and tell me the answer. N2 is 4 and n1 is 1. So tell me. So half into n2 is 4 minus 1, it will be 3. Again here 4 minus 1 plus 1 becomes 0. Okay, here how much? 2 times, so 3 to the 6. So we got 6 lines. So here also practically if we draw them also we get 6 lines only. Is that clear or not up to here? Yeah. So now write one more question. Write one more question. Number of possible spectral lines when an electron falls from fifth energy level to ground state. Fifth energy level to ground state. Done? Again one more question. Fifth energy state to first energy state, that is done. Second question you can write fifth energy state to first excited state. Fifth energy state to first excited state. Okay? I know you can able to do that. So just look at here, I am going to teach you one more important point here. One more important thing here, look at here. See here we have 10 lines possible here in this case. Now how many lines falls into the Lyman series? What do we mean by Lyman series? From any higher energy state to ground state if electron is falling, or the transition we can call it as Lyman series transition. What is that? Lyman series transition. Any higher energy state to ground state, n1 equals to n equals to 1 state. Okay, and any higher energy state to second energy level. What we have? Balmer series lines. From any higher energy state to third state, past tense. Any higher to fourth state. Any higher to fifth state, fund. Any higher to sixth, Hamfer. These are the spectral series we have. Okay. So now an electron falling from fourth energy state to second energy state. In which series we can see this line? It belongs to fourth to second I am saying. So second it means Balmer. Fifth to first. Fifth to third. Clear na? Now I am asking number of lines falls into Lyman series when an electron falls from fourth to first state, ground level. Look at here, fourth to fall. How many possible lines we can get in Lyman series? Lyman series. Lyman only. Particularly asking Lyman. See, 4 to 1, one line, 3 to 1, second line, 2 to 1, third line. Is that clear? Bracket series lines? Bracket series lines, anything? Already 4. Bracket. I am not asking Balmer. There is no possible for bracket. Okay, now asking about Balmer, tell me. See, any higher energy state to second state. Second means 4 to 2, 3 to 2, 2 lines. Like this also we can expect a question. Or one more possible simple question here I can say, what are the H alpha numbers? It means this first line is there now. In every series, this first line is there now. This first line you are seeing now, you should call it as H alpha line, or I can say first line. This second line you can call it as H beta or second line. Like that, this will becomes H infinite line or last line of the series, because from infinite level to first level it is falling. Then you can call it as H infinite. Is that clear? So now, what are the n values for H alpha line of Lyman series? What are the n values? I mean n2 value and n1 value for H alpha line of Lyman series. 2, n2 is 2, n1 is 1. Is that clear? Now for Paschen series, what are the H beta values? H beta for Paschen I am asking. Paschen means from any level to third state. Okay, so we know definitely n1 will be 3, fix it. Now I am asking beta line now. See, this is alpha, this is beta. So beta from where to where? 5 to 3. So n2 will be 5. Is that clear? These things also they may ask us. Okay, hope it is also clear. Let us move forward with something more interesting. Now all the Lyman series lines will appear in this UV region. Okay, I suggest you to write this thing whatever we discussed in the previous slide. Okay, that and also this one. Okay, so Lyman series lines appears in UV region. Balmer series lines appears in visible. Paschen appears in infrared, IR. Okay, you just remember these are IR, this is near IR, mid IR, far IR, like that you can remember. So first thing is Lyman UV, visible, visible is Balmer appears in visible, Paschen in IR, bracket, fund, for all are in IRs. Okay, clear up to here? Next, this is done. Now, if we ask energy difference, for example, electron falling from N2 to N1, there is some energy difference now. Let us indicate that with delta E. Okay, so you can simply use a formula that we discussed, delta E equals to 13.6. Okay, that is energy formula. So here I am making difference now. So 13.6, 1 by N1 square. See here, what is the formula you have studied? Minus 13.6, minus 13.6 Z square by N square. Okay, so since we are discussing energy difference, that will be usually for single atom only. So that Z square also becomes common now. So 13.6 into Z square I am writing into 1 by N1 square minus 1 by N2 square. What is the units? Electron volt per atom. So this is in terms of electron volt per atom, or we have other terms also like joule per atom also we have now. This formula you can write. Okay, so now here we can also find, sometimes they may ask what is the wavelength value. Okay, so for this, see, we generally have now E is equals to H nu, Hc by lambda we have now. They are asking lambda, then what you can do? E by like Hc by E you can do right now. So inverse 1 by lambda equals to E by Hc. So here I am taking 1 by lambda is E by Hc. Okay, so that is equals to RH Hc, something like this you are seeing now. So now you just remember this formula, and here one more formula I am saying, 1 by lambda equals to, this 1 by lambda is also called as wave, this is inverse of wavelength na, we can also call it as wave number. Okay, I hope you know this. This is equals to RH z square 1 by n1 square minus 1 by n2 square. Okay, always remember this, this n2 should be greater than n1. Okay, and here RH is called as Rydberg's constant. Okay, and this equation is Rydberg's formula, we can say. Okay, so the value of this Rydberg constant I can write. So 1.1 into 10 power 5 I am writing, 5 z square 1 by n1 square minus 1 by n2 square centimeter inverse. What I am writing? Centimeter inverse for lambda, 1 by lambda. Okay, and this is 7 power 7 for meter inverse. So both you can use any of this depending upon the requirement. Okay, hope up to here it is also clear. Yes, write it. Done? So up to here it is done now. Let us look some questions, any possible questions we can able to do from this or not. Look at this. The series that corresponds to transition from higher energy level to n equals to 4 in the hydrogen spectrum. Bracket. Very easy now. Fourth option. Okay. So you won't even waste your time in this. And here, are you able to do this? The ground state energy of hydrogen atom is minus 13.6 electron volt. Okay, and assume Hc is given like this. Okay, the maximum wavelength in Balmer series is approximately. See, Balmer series, what they are asking wavelength na? What is the formula we have studied last? Wavelength formula for n1, n2 values. What is it? 1 by lambda equals to 1.1 into 10 power 5 into 1 by n1 square minus 1 by n2 square centimeter inverse. Right now? So now, what is the n1 and n2 values over here? Balmer series na? N1 will be 2, should not get stuck here. N1 should be 2, and see again we need this kind of equation, right? So let us make it which will be maximum, which will be minimum. That should be clear to us. So I will be telling you for that you can use 1 by lambda, this RH, Z I am taking 1 for hydrogen. So 1 by n1 square minus 1 by n2 square if you use. Okay, so take this RH into, so n2 square. See, if I take from infinite level to first level, second level, Balmer series na second level. Okay, so second level means this n2 value is how much now? Infinite. So this value becomes 0, something by infinite 0 now. So it will be 1 by 2 square. So this is 1 by lambda. So lambda becomes what? 4 by RH. Okay, this is from infinite level. So what is the other condition we can say? Minimum, maximum they are asking. So to avoid confusion, there are only two possible to get confused. One is from infinite to second level, another one is from third level to second level. So what is the second level that is possible? 1 by lambda equals to RH. For hydrogen, let us say 1. Okay, Z square is 1. Here 1 by 2 square, 1 by 3 square. That is, okay, 3 square, let me write. RH, this will be 36, 4 in 9, 36 here. And what about here, what I can write? See, 1 by 4 minus 1 by 9 means RH. So how much it will be? 36. 9 minus 4 will be 5. Plus 5 only. Okay, this, 36.
Now if we reverse.
Lambda will be 36 by 5 RH. Okay, so this is how much? 4 into 1 by RH. And here it is 36 by 5 into 1 by RH. RH is common in both cases. Now tell me, here 4 into this thing we have, and here 36. How much we will get? This is 5. 7 is 35. So which is bigger here? Lambda, where we are getting bigger lambda? Wavelength is bigger in this case. So you can say maximum wavelength is in this case. So what is our N1, N2 values?
N1 is
2, N3, N2 is 3. So take that N1, N2 values here, substitute here, you will get one of the answer out of these 4 options. Clear with this? Maximum means 3 to 2. Minimum means, that's it. Okay, done with this also. Calculate the wavelength of alpha particle, if the mass is given, velocity is given. Okay, so what are the things they given? Mass given, velocity given, asking about wavelength. Now here itself I just wanted to conclude the de Broglie wave equation also. I do not want to go to the slides again. So what is de Broglie wave equation we get? See, from we know light has dual nature now. So now I am taking from classical mechanics E equals to mc square I am taking. Okay, and from Planck's quantum theory what we have studied, E is equals to hc by lambda. Both are energies only. From these two I can write mc square equals to hc by lambda, c square c cancel. Okay, so lambda becomes h by mc. Can I write like this? Okay, so what is m here? Mass. C is speed of light. In case of light, it is a thing you need to consider. In case of other than light, so for particle lambda becomes h by m is the mass of that particle. If particle is electron, so take mass of electron, and c becomes now velocity here, velocity of that particle. If electron, take the velocity of electron. Is that clear? So what is the final conclusion we got? Lambda equals h by mv. Okay, so this is the de Broglie wave equation, you should remember. Okay, now put here and tell me the answer. So lambda, wavelength. Calculate the wavelength of alpha particle if its mass is c, h by mv. So h is how much I told you? Planck's constant. See, they are giving the values also in the question itself. 6.6 into 10 power minus 34 joule second. Okay, and next, what about mass? Mass is given like this, see, 6.6 into 10 power minus 27 kg into, what about velocity mentioned? 2 into 10 power 7 meter per second. So look at here, our answer should be in terms of second answer. Let us look into this. See, what about joules? I can write joules as kg meter square per second square, right now. So put here the value 6.6 into 10 power minus 34. So kg meter square into second, okay, by 6.6 minus 27 plus 7 minus 20 kg into 2 only, no? 2. Okay, here we have meter per second. Okay, so see, per second square into second, here again per second completes per second is removed. Meter square is removed, kg removed, we are remaining with what? Just 1 meter we are remaining. Our answer should be also in the terms of meter. See, same units we are getting means our answer is almost correct only, nothing to worry here. Okay, if you are not getting exact units, it means you are doing something wrong here. Okay, 6.6 removed, this will be 10 power minus 14. So 1 by 2 into 10 power minus 14 meters we have. So I can write it as 5 into 10 power minus 15 meters. Is that clear? So option number 4. Okay, hope it is also clear. Now if any other question possible. This is again easy question. Tell me. Radius of first Bohr orbit of hydrogen is given, the radius of second Bohr orbit. Very easy. You have solved this question. Radius formula? So this, see, 529, for calculation purpose they are taking it as 5.3 also, no issues with that. Into n square by z. Okay, we know for hydrogen atom both are 1, for first Bohr orbit that will be this much only. That is fine. For they are asking for second orbit of hydrogen atom. So R2 will be 0.53 into Z will be 1, N will be 2 square. So 4 into 53. How much? So 12, 2, 1, 2 decimals. So 1.12. Here we have 1.12 angstroms. Very easy, now. No time waste time, nothing here in this. Okay, next. Is there any other possibility? Yes. I hope you can able to do this question also. Okay, I don't know whether there is mistake or not. So take this as 10 meter per second. Okay, velocity or speed you take 10 meter per second and tell me your answer. So see, I am not solving any other model questions also. We are solving purely your previous year questions only. Hope those who are watching in live are utilizing this properly for their preparation. Yes, if it is really useful, just share your feedback in the comment box, and also you can express through the like button also. Yes. Yeah. Got the answer? Tell me approximate number at least. Yes, you can get the exact. So 3.9. Yeah. I want answer angstroms. Angstroms. Convert that meters to angstroms, you will get exact answer, no? Anyways, you are using calculator, no man. You can get exact answer also. 1 angstrom, like 1 meter, 10 power 10 angstroms. Or you can say 1 angstrom, 10 power minus 10 meters. I suggest everyone to focus 1 or 2 days only on unit conversion. It will be useful in all your subjects. Like I think sometimes in bio also you will get now. Fully focus on unit conversions one day. Okay, and next see what are the other questions they are asking here is from this chapter. If you see, there is something like radial nodes, angular nodes, something like this, and one more thing is nodes only. Here also nodes only. It means you should know little more about the quantum numbers. Okay, so complete quantum numbers are also not required, but anyways if you learn that, you can answer this kind of questions or anything around surroundings of this you can able to answer. Okay, so let us discuss that in the next session. Okay, so thank you for watching those who are in online. So stay connected with this channel, it will be very useful for you. If you haven't subscribed the channel yet, so just click on the subscribe button so that all the notifications will come without any delay. Okay, so thank you.